Bert Hamner is the president of Hydrobee. Dr. Zaifeng Ren, module advisor. Anderson Chair, Professor, Department of Physics, University of Houston. Director of the Texas Center for Superconductivity. So Bert has been a clean tech champion in Seattle since 1991, when he was one of the first business assistance experts hired by Washington Department of Ecology to help them reduce pollution through better technology and management. He later brought those skills to USAID, the UN, and World Bank, and spent 25 years in 25 plus countries helping thousands of businesses through training and factory assessments. Returning to the USA, he founded an ocean energy company and led the first major study of tidal power in Washington state. Then he founded a hydrokinetic turbine company, Hydrovolts, to develop new power solutions, raised over $3 million for that company, and won many prizes. The company was acquired by some of its investors, and then founded Hydrobee to develop personal scale clean energy projects. There we go. I see your slides and I see you. Go ahead and take it away. Welcome to our virtual stage.
Thank you very much. It's a pleasure to be here. So today I'm going to be talking about new technology, repurposed technology that's going to make a difference, we hope, eventually to an awful lot of people. So the problems we're talking about begin with an understanding of scale, or this is the best analogy I've ever heard about the difference between a million and a billion. A million seconds is 11 days. A billion seconds is 32 years. Something to think about. So as we get into this, the problems here, in developed countries, over 90% of the homes in the USA and similarly around the world don't have any backup power source for phones and lights, all of which run on USB power now. And yet extreme weather is causing increasing blackouts, and it's a major concern in many, many countries. But in developing countries, we still have 1 billion people who have no or unreliable electricity. And 3 billion people are using inefficient and smoky stoves. And 4 million people a year are dying of the smoke from breathing from those stoves. This is one of the biggest causes of preventable illness in the world. And Americans and people in developed countries just don't tend to understand this because we don't have houses full of smoke. But it's a huge problem. And yet new clean and efficient stoves are too expensive for most of these people. So they have to have some other way to pay for it other than upfront cash. Now, the problem of dirty, smoky stoves is so significant that it's estimated that the emissions from inefficient stoves, the excess emissions, are estimated to be in the top 10 of all global emission sources. Project Drawdown ranks clean cooking as number 10 out of 100 best solutions to reduce emissions. And they estimate that if most of the inefficient stoves now in use could reduce emissions with clean technology, it would save 30 plus gigatons of carbon over 30 years and save the stove owners billions of dollars in fuel and save literally tens of millions of lives. All for a problem that we here in the United States tend not to even recognize exists. Our solution is a thermoelectric generator, which makes USB power and 12 volt power from the waste heat in stoves. And so we can make any stove now into a power generator. Any fireplace, gas, or biomass stove, or an open fire on the ground. And that power can charge batteries and phones and LED lights for giving mobile networks and Wi-Fi connection. It can run a fan that ventilates the stove and creates better combustion. And in fact, we have a new stove blower called the Jet Flame. And with its use, the fuel use cost and emissions from an existing stove can be reduced by 50%. And it can be run on 1.5 watts of power, which is made by the stove itself. And by reducing the smoke, of course, it saves people's health tremendously. So it's working today. We have the product up and running in several different situations. Here's one in the backyard of a house. Here's around a small pot stove. There's a ring here. I'll get back to these. Here's on a pellet stove, an outdoor heating stove. Here we're using a can of Sterno alcohol gel. Can make power with it. And then over here we have a demonstration of it using a heat pipe to displace the generator from the stove itself. So a little bit more here is my colleague's backyard who built this. You have a heat source over here. It's a propane barbecue. It's heating up a cast aluminum block, and in there is a heat pipe that transfers heat to thermoelectric modules here. And these towers here are full of water. They act as cooling towers. The water is heated up at the base, and it goes up and it starts convection in the towers, which strips the heat away to the atmosphere to maintain that temperature differential. This is making 80 watts of power. This is enough to light up a small home with LED lights. Here we have in Pakistan a typical small charcoal fire that is used, and we've put an aluminum ring around the top of it that's connected to the generator. So while the person's cooking, it doesn't interfere with their cooking at all. This is just waste heat that would go up around the sides. And they're making 10 to 15 watts over that. Over here on the right, you can see one of these stoves made by Burn Manufacturing, which, by the way, was launched here in Seattle and in Oregon. And they've sold over 1 million of these stoves, and all of those stoves can now use this solution to make electricity. Here we see the heat pipe solution here on a small burner. My colleague, Amir Bhatti, who has built these, has been able to make these heat pipes as long as 40 feet. And he's confident that a 20-foot heat pipe can be done. So with this situation, which can go around corners and it can go up and down, we can reach into a facility or a building to a heat source and start turning it into electricity, as long as it's waste heat. And this is my backyard and my lovely wife Annette, who's just, we've got the generator's been attached to a chimney section. So we just remove one section from the chimney, put this one in, it takes 5 minutes, and we're making 10 watts of power to light up the backyard. But now imagine, of course, if you have no regular electricity and this is replacing a kerosene lantern. Then the jet flame stove blower, this was developed here in Seattle and in Oregon by Global Good, part of Intellectual Ventures. And their goal was to increase combustion efficiency. So this new blower uses only 1.5 watts of power. It's the most efficient thing in the world. Inserted into the side of the stove, into the firebox here, it reduces fuel emissions and costs by up to 60%, reduces smoke up to 80%. And because it's hotter, it cooks about 50% faster. This device costs $13 to make, and it's able to work on 100 million stoves in place now. But how can people afford this if they don't have any money? Well, the answer is that a generator that's connected to the internet can be turned on and off remotely by the vendor. And that makes it possible to sell the device with monthly payments, the same way poor people are buying their phones in developing countries. In Africa, pay-as-you-go over mobile is exactly how they're selling tens of thousands of small solar systems a month. And as an example, because you're saving money on fuel because you have a more efficient stove, you pay $10 a month for the stove and the blower, but you save $15 a month on fuel. So you come out ahead every month. And then after, say, a year and paying $120 in total, you own the stove and the generator. This technology is already in place. We don't have to do anything to set up except put the chip necessary for this operation onto the generator. We've also got a new development that just happened just a couple of weeks ago. We've signed an agreement with a company making a graphene-based lithium-ion battery that charges 8 times faster than all the other power banks available on the market. Why is that important? Because it means you don't need to use as much fuel to get a charge. And if you're doing solar, of course, it means that you can charge, well, here you've got normal charging is 120 minutes. This charges in 17 minutes. So in 2 hours, you can either charge one regular phone or you can charge 6 of these new batteries. This expands the feasibility of small solar and small wind across the planet incredibly. And it's $60. It's cheap. How big is the market? Again, I told you at the beginning that these markets are immense and we've got to keep it in perspective. As I said, only a few percent of US homes have a backup generator, but there's 150 million Americans that own a grill or a smoker, and they can use this device to make power if they have a blackout. 40 million homes have a fireplace and 10 million have a wood stove. So a backup power source under $200 that's not dependent on the weather. In other words, it's not solar or wind. We figure that there's a market at least 50 million units potential in this country. As an example of a developing country, Pakistan, where you saw some of these pictures earlier, 220 million people there, but 51 million still have no power. And 100 million of the people have constant blackouts because the grid's terrible. So for a power source that costs them 15 a month with PAYGO financing, we estimate there's a market for at least 20 million units just in Pakistan. And keep in mind, and much of Pakistan is up in the mountains. So in the winter, they have very low solar insolation. And so having something that works when they cook is a big benefit. So 500 of these have been sold around the world. 120 of them have been installed in Pakistan by my partners. We got patents for the key components. Oregon State University's humanitarian engineering program has been working with us for over 2 years, putting the generator on different types of stoves and building out a full engineering base for it. And the Aprovecho Research Institute in Eugene has been testing and proving the products out. And we've also been contracted with Pacific Northwest National Lab, who's helped us develop a new heat sink with their thermal modeling technology. There's still only one other stove in the world commercially available that makes electricity. It's the BioLite stove, and it's been out on the market for 12, 15 years, but it hasn't taken off because the generator's integrated into their stove. You can't use it anywhere else, whereas ours can be used on any stove. So any heat source, it's massively scalable, and we do have IP in development, and we intend to maintain the low cost production lead because our entire system with a new stove and a generator connected to the internet is going to have a cost of less than $100. I've got a great group of people helping me out. I won't spend time on them, but a number of them are from the Northwest, and I'll speak to about Dr. Zhifeng Ren in just a minute. So we are looking for support in a number of areas. We're looking for partnerships. We're looking for legal and help, and of course for funding to develop this. Now I'm going to switch gears for a minute and talk about a breakthrough in the technology here that's incredibly important because of its implications. So we use in our device a thermoelectric module that's about 40 millimeters on a side, 3 millimeters thick, and the hot side is when the heat goes from the hot side to the other side, the cold side, it makes power. And a couple of years ago, I learned that Dr. Zhifeng Ren at the University of Houston has developed a new type of this product that works very well. It works a lot better. So very briefly, these modules, which end up looking like this or the other one, they start off with a bunch of very small modules internally that are stacked together, put together, packaged together. And as a consequence, the manufacturing process is fairly extensive, and in low volumes, it's done mostly manually, which means it costs a lot. So what Dr. Ren has come up with is 2 baseline module solutions for TEG applications, all of which are compatible with existing manufacturing. So no new factory is necessary to make this work. And what's their previous experience here? Well, Dr. Ren has got more than 20 patents on TE related materials and published more than 200 papers. They started off at Boston College with MIT and NASA, created a company funded by Kleiner Perkins and others back in 2006. Then later moved to Houston, where Dr. Ren's also the director of the Texas Center for Superconductivity. I connected with him in 2019 and explained that the stove temperatures in chimneys where we want to work with is 250 to 350 C. And I asked him if his new concepts would work. He said, oh, yes. So what's the issues? So currently the modules in the Firebee unit have an efficiency of 3 to 4%, and that's the industry standard. The tellurium component in the modules is quite expensive. That's the main cost of it. And production volumes have been relatively low which leads to higher cost. So if you're trying to do waste heat conversion at a scalable, commercial, industrial level, to get more than 10 kilowatts, which is not much, you have to wire thousands and thousands of modules together, like wiring together the scales on a fish. And the design cost is high, and the installation cost is high. And there was no mass market for making lots and lots of modules. Nobody needed them until we came along with stoves. So the Houston R&D has come up with a new way to make these modules by eliminating expensive tellurium and demonstrating high efficiency. And Dr. Wren gave me this wonderful slide to explain, which I will not do at this time, demonstrating their data. And after this, you'll be able to contact him directly. But I want to bring up this particular thing, showing conversion efficiency of heat to energy. And they're reaching at a temperatures of 400 to 500 degrees C, 10 to 12%. Now, remember, I told you that right now the modules are 3 to 4% efficient. This is a 3x increase in efficiency. So they built an engine to test it. They got a maximum power of over a kilowatt off of heat from an exhaust. It works. So to make the bottom line really clear, what they've done at Houston is they've managed to develop a module that produces half the cost and twice the power of current ones. So that's 4 times as many watts per dollar. And what does that mean? It means that we can increase the return on investment for industrial and commercial waste heat conversion by 4x. And why does that matter? Because we want to start creating a company that will start making these modules and then getting them into the field. So Dr. Wren is estimating that about $5 million is needed to set up production and 12 months to shipping. And then to create partnerships where we can have applications in stoves where millions of modules can be sold, thereby driving up production and driving down cost. And that leads to access to the commercial market. As an example in commercialization, here in Seattle, there's a very large steel mill, which many of you know about. And a few years ago, they evaluated the thermoelectric application to make electricity from the waste heat of cooling steel ingots. These are steel bars right out of the furnace, 2,000 degrees C. It takes them 2 weeks to cool off in the open air. And they decided to try to look at thermoelectric heat energy recovery. They could not quite get to the corporate hurdle rate of 25% ROI. But new modules that are 4 times the watts per dollar will get them to that ROI that they need, and they're very excited about it. Because low-grade waste heat is everywhere. And so we now believe that with this new technology from Houston, that 1 to 100 kilowatt solutions are now feasible in tens of thousands of facilities. And by deploying the new modules on millions of stoves, it drives the costs down, and then the industrial applications can go with more reliability. Dr. Wren is excited to talk to anybody about this, and here's his contact information. And in summary, we have a working solution that matches to billions of people. It helps with energy poverty. 1 billion people all have stoves and no electricity, and now they can have power. We can eliminate indoor air pollution from dirty stoves. We can reduce billions of tons of CO2 from going into the environment. By the way, also reducing deforestation because they don't need as much wood. And it's all affordable at $10 a month, perhaps, over mobile networks. And finally, this opens up the door to industrial waste heat conversion throughout all of industry and commerce. So we're very excited to collaborate. And I think that here in the Northwest, there's a lot of potential to become the world center for this activity. So thank you.
Great, thanks, Bert. Could you go ahead and go back to the previous slide and leave the other contact information up for just a second longer? I know I didn't have time to get it all captured, so there it is for anyone that wants it. We had a question in the chat from Peter wanting to touch a little bit more on the clean stove piece of your solution or what you interact with. His question was, how does this clean the smoky air issue, and did I miss something? He gets the electric generation part.
Can you say the question again?
His question was, how does this clean the smoky air issue?
Oh, sure.
I'm sure I missed something. So just pick that thread back up again for a second, please.
Sure. By generating power, we can then run a stove ventilator, that jet flame blower. And the jet flame blower pushes air up into the combustion box to double the combustion efficiency. And that means that it burns with much, much less smoke. The other thing it does is it makes it possible, the power makes it possible to sell a new stove with a chimney. What's remarkable is when you go out to developing countries and you see the way people cook, their homes are full of smoke. And you just simply say, why don't you have a chimney? We can't afford a chimney. And so it literally kills 4 million people a year. Most of them are women and young children, because they spend all their days hovered over a smoky stove. It's a terrible problem, but we can reduce it by increasing the combustion efficiency and by providing a chimney with a new stove.
Let's see, next question. Is this more efficient than Peltier devices, and roughly what percentage?
They're different. They're different because we're converting heat to electricity, whereas Peltier system is turning electricity into cooling power. And I don't know how to compare the efficiency of those two functions, so I don't have an answer. It's just that they're different.
Next question was, we could probably use coal with this.
Coal is a heat source, sure, absolutely. The key is we don't want to have people burn more coal to make electricity. So instead, we want to be able to put this into the chimney where waste heat from combustion is going up. So we're not asking anybody to burn anything new. We're recovering the waste heat.
Can you answer my curiosity? You're talking about putting this in off-grid homes and locations, and I really appreciate that you're speaking to the impact on smoky environments on women and children, and the social inequity issues in those homes and those locations. What degree were the markets you're wanting to sell these stoves and these devices into consulted? Did some of the women using the stoves have the opportunity to help design and test? And are you clear that they would implement them? I see how you've overcome the affordability issue, but are they satisfied with the cooking production and the impact on their lives to switch to this technology?
We've only deployed, well, my colleagues in Pakistan have deployed 120 units, and they did that in 2016 and 2017. And at the time, they had wonderful reception. People were thrilled by it, and they showed that they were able to continue cooking the same way they always have. And that's really a key thing, is with the use of the heat pipes, you can stick a small copper tube into the combustion chamber of the stove they already have and not affect anything. And so that's real important, because resistance to change is a critical problem. Stoves are very intimate to people. And usually in a stove in a developing country, who's running the stove? It might very well be grandma. It's certainly not dad. And so as a consequence, you have the problem of, consultants coming in and saying, here's a bright new shiny stove to use. And they say, thank you very much. And later on, it's a flower pot. They don't use it. So the key is to make the new stove so attractive to use, with so many benefits: power, less smoke, faster cooking, save on fuel, that grandma will be convinced by her children to use it. And the other part is affordability. It's got to be able to be sold with small payments. Otherwise, 1 billion people simply cannot afford it up front.
Okay, great. Last call. Any final questions for Bert?